Scientific notation was designed to make it easy to work with very large or very small numbers, numbers that are often encountered in scientific study, say of astronomy or nuclear physics. So I'm going to give you the overview, a review of the overview of what it all means, and then make sure that you know how to do this on your calculator. So if you feel confident of the overview, you can forward ahead to the other, the calculator portion of it. So we have talked at length and you have in math classes, about multiplying and dividing by powers of 10. What I mean is this: you first learned that 5 times 10 was 50. In later years, you realized you can't just add a 0 because 5/10 times 10, which also we could think of it like 5/10 times 10, is only equal to 5. And from this, I'm not going to go into all the details of this, we learned that when multiplying by a power of 10, and by power of 10 I mean 10 to the 0, 10 to the first, 10 to the second, or you can think of these with a 1 with that many zeros, although we know, I hope you know, that 10 to the 0 power, I'm going to fix that 0, is equal to 1. 10 to the first power is a 1 with 1 0. 10 to the second is a 1 with 2 zeros. 10 to the third, a 1 with 3 zeros. And the basic rule of thumb for multiplying by positive powers of 10 is that we move the decimal point over as many places as we have zeros, which is also the same as 3 zeros is 10 to the third. 2 zeros is 10 to the second. 1 0 is 10 to the first. So what that all boils down to is very handy-dandy shortcuts for multiplying and dividing. That's what scientific notation is based on. The one tricky thing about scientific notation is that it is a very clear definition of what it means. The official words sound like this. Scientific notation is a number that's expressed as the product, or an expression of the product of a number greater than or equal to 1 but less than 10. In other words, it's going to have one decimal point to the left, one decimal place to the left of 0, because it's greater than or equal to 1, so the smallest thing it can be is 1. And it has to be less than 10, so the biggest thing it could be would be 9.9 blah 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 blah. No matter what we do, it always, this is the important thing, in order for it to be scientific notation, the definition is clear. There is one place to the left of the decimal point. So it's a product of a number like that, and product means times an integer power or integral power of 10. So that means, I'm not even going to write those words, it means 10 to the some number power. So if I say 2.3 times 10 to the third power, it is in scientific notation because there's one digit to the left of the decimal point multiplying with an integer power of 10. 3 is an integer, and this is the power. Now, as we saw before, this is the same thing as a 1 with 3 zeros. So the number that this scientific notation represents is 2.3. I move it over one place. I still have 2 to go. Or 2,300. I'm going to do a couple more just with big numbers. 8.4 times 10 to the 6th. I know it's going to be 8.4, and I have to move it 6 places, so 1, 2, 3, 4, 5, 6. Notice there are only 5 zeros. I am not adding 5 zeros. I am moving the decimal point over 6 places. If I say 0.84 times 10 to the 7th, that also equals this number, because I'm starting here, in this case, and I'm moving it over 7 places. However, This is not scientific notation because the decimal, there was not one decimal place to the left of the decimal point. So that's how we go from scientific notation to a number, a decimal number. If I want to number to scientific notation, I might have the number 58 billion, actually billion, 500, 120 million, very big number. Now, where does my decimal point have to go? Right here, because there needs to be one decimal point to the left, so I know my scientific notation will be 5.8. Now I'm working backwards. How many places, well, I can stay here, how many places would I have to move that to get to the number that we started with? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's times 10 to the 10th power. So I place my decimal point in the prearranged spot, and then I count how many places to the end of the number. So if I say 3, 4, 0, 0, 0, 0, 0, 0, here's where my decimal point goes. So it's going to be 3.4. Then I have to go 1, 2, 3, 4, 5, 6, 7 places to get to the end. So that's times 10 to the 7th. Now, we talked about negative exponents yesterday, so let's do that with the powers of 10. We have 10 to the 3rd. Well, actually, let's start with 10 to the 1st. 10 squared. This is a 1 with 3 zeros. This is a 1 with 2 zeros. That's 100. This is a 1 with 1 0. As I move this way, I'm dividing by 10. 10 divided by 10, and we know 10 to the 0 power is 1. And we said 10 to the negative first power is 1 over 10 to the positive first. We know that also is 0.1, 1/10. 10 to the negative second is the same as 1 over 10 squared. Okay? So if I am multiplying, say, by 1/100th, if I say 500 times 1 over 100, I'm actually dividing because the 100 is on the bottom. And when I divide by a power of 10, it's just like multiplying, only the reverse, because they are inverse operations. So 500 divided by 100, I move my decimal point, but now it goes to the left 2 places. So similarly, if I want to say, I don't know, 6.3 times 10 to the negative 3rd, that means the same as 6.3 divided by 10 to the 3rd. That's the whole idea of negative exponents. If I'm dividing by a power of 10, I'm dividing by a power of 10 or multiplying by -1. I'm moving the decimal point 3, and you can think of that. Negative sounds like 3. I'm moving it 3 places to the left. 1, 2, 3. So my decimal equivalent for 6.3 times 10 to the negative 3rd is 0.0063, or 63 10,000ths. And we'll talk about going from a decimal number to scientific notation. If I say 4.65 times 10 to the negative 7th, that's the same as dividing by 10 to the positive 7th. So I have to take my number, 4.65, and we saw this yesterday also. Negative exponents are not talking about negative numbers, they're talking about very small numbers. So I'm going to move it 7 places to the left, because it's a negative exponent. 1, 2, 3, 4, 5, 6, 7. So it's a decimal point with 6 zeros, and then 4, 6, 5. So going in the other way, if I'm looking at my number, okay, I've got a decimal number. Now, with scientific notation, I always need to have one decimal place to the left of the decimal point, so I know my decimal point will be going here. And to get to my original number, I have to go 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the left. So this is equivalent to 8.23 times 10 to the negative, what did we say? 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative ninth. Okay? So you always put your decimal point in, and then see how far you have to move the decimal point to get to the original number. So, one more time. Let's just put a whole mess of zeros. Okay. Here's my decimal point, because there's always just one place to the left of the decimal point. And to travel from here to where it is, I have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's times 10 to the negative 12th. And my decimal was 6.342. So that's how scientific notation works. Now what's valuable about this is that we can also use it in calculators. Different calculators obviously have different displays, and you should get to know your own. We have a Texas Instrument TI-30X. Those are the ones that are in the classroom. So I'm going to talk about how to use those. If I want to multiply, I don't know, let's see, 3.2 times 10 to the 7th, and multiply it, with 2.5 times 10 to the negative, 20th. To enter into my calculator, I have to do 3.2, and then I need my E button. The EE button, or E button, means times 10 to the. That's what it means. And the way we get there is to press on our thing second, and then x to the negative 1, because in blue writing, you will see underneath that it says EE. Do not touch the multiplication button at this point. So we do 3.2 second, x to the negative first, and that means times 10 to the, and we are trying to raise it to the 7th power. Now we press the multiplication button, because this is where we are here. We're multiplying that times 2.5 second, x to the negative 1. And then this is important, the next thing, and even though I'm out of room, you can't use the subtraction sign for the negative 20th. You have to use the negative sign and then 20. And when you press equals, sometimes you're going, if the number fits, it will display it as a decimal. And then you can do the second, and then look for DRG right next to it, which above says Sci Engineering. And then cursor over to SCI and hit enter. And it will give you the number in scientific notation. On your test, I really am going to expect you to be able to do this using a calculator. It's not that hard, really, to do it otherwise, but the decimal points can get tricky. So it's a good thing to know how to do. Talk about what that would be in division. If I say 3.2 times 10 to the 7th, divided by 2.0 times 10 to the 4th. Okay? I enter 3.2. EE means times 10 to the. So now I just have to write 7 because that's times 10 to the. And this time I'm going to divide, divided by 2.0 .0, but you don't really need the .0. Oh, no, Mary, don't do times. We need to do EE 4 equals. So 3.2 times 10 to the 7th divided by 2.0 times 10 to the 4th equals, and your calculator could express it as this number. Now, it's not hard for you. All your answers on the test have to be in scientific notation, so let's just practice. That's 1.6 times 10 to the 1, 2, 3. Or, on your calculator, you can hit second, sci, and then cursor over and enter, and then way in the lower corner it will look like this, 1.6. And really, in tiny letters, it'll say times 10 to the, and above it will make a big 03. You need to, if you use your calculator, you need to be able to read that number. All right, so that's really all you need to be able to do. Make sure that you can do this with your calculator.